All right, this is for Chemistry 1151. This is section 9.9. We're going to talk about titrations in this section, and this is definitely relevant to you if you're taking the lab portion of the class this semester. The titration is just an experiment to determine the concentration. It could be of an acid or base. We're specifically talking about acids-base titrations today. But to determine the concentration of something we don't know by using something we do know the concentration of. So comparing those two substances will allow us to get an unknown concentration. We react an acid with a base slowly until it's neutralized. When it's neutralized, the moles of the acid and the moles of the base are the same. We call this the end point of the titration. You may also see it written as the equivalence point. Equivalence being the moles of acid and moles of base are equivalent. Sometimes the end point is a little bit after the equivalent point because the end point is where we stop. And sometimes we're not fast enough to catch it right at that point where they're equal. And sometimes our endpoint is a little bit later, but you'll see that if you actually go into the lab and you do it, like you'll learn that when you stop your titration, when you're notified, hey, the pH is changing or there's a color change in whatever indicator that you're using, usually the endpoint is a little bit past the equivalence point, but that's okay because we try to get it as close as we can. So this is some pictures of what a titration can look like. We have an acid down here in this flask with a base and this equipment called a burette. We're dropping the base down into the acid and it's turning pink. It's turning pink because there's an indicator in the acid that is pink when it's basic, but colorless when it's acidic. And so we know when it turns basic that it has gone past that equivalence point. So now moles of base are greater than moles of acid. So we try to get it as light of pink as possible to get it as close to that equivalence point as possible. I'm not going to go into too much detail here. You don't need this for the lecture, but for a lab, you will probably be experiencing the indicators here and doing an experiment similar to this. So how do we do the math? We take the volume of the base that we use. Let's say we use sodium hydroxide. We use the molarity as a conversion factor to get moles of the base. We use a mole-to-mole conversion factor to get some moles of the acid, let's say hydrochloric. And then we use the molarity to get we use the liters. Well, so we'll input, I guess this is kind of wrong. Let me change this really quick. So we're not going to use a conversion. Whoops. We're not really going to use a conversion factor here. We'll take the moles of our acid and then we'll divide it by the liters of our acid to get the molarity of our acid. That should make sense. So we're going to take the moles of our acid, we'll add in the liters of HCl. And the molarity, remember, is the moles over liter. So we take the moles of our acid divided by liters of our acid to get our molarity. So really, it's all conversions you can do. It's just different orders of solving problems and different orders of conversions in algebra. So let's look at an example. What's the molarity of a hydrochloric acid solution if 22.5 milliliters of a 0.100 molar sodium hydroxide solution are needed to titrate a 25 milliliter sample of the acid? So I don't know the concentration of HCl. What am I looking for? I'm looking for the molarity of HCl, which is going to be moles over liters. So we kind of have two unknowns. So we're going to start to find our moles and then find our liters. Well, you may be thinking, well, liters are pretty easy to find. I have milliliters right here. Exactly. So the liters are pretty easy to find in this case. So we're going to be using these two pieces of information to find the moles of HCl. And we're going to need one more piece of information to help us with that. We'll need to also have the chemical reaction. So if we look at the chemical reaction, they have it here. So let me just write it up here so that they're doing this in an order I don't really like so much. So we have HCl plus the NaOH. We do a neutralization reaction. Remember, this is a double replacement. So the H goes with the OH to make water, and the Na goes with the Cl to make NaCl. And this is balanced as is because it's just one of each thing. And if we want to find moles of HCl, we need to use a mole ratio. So it's 1 to 1 for HCl and NaOH. And then remember that molarity is actually mole per liter, so we can use that as a conversion. Why don't you try this? I know it's kind of a lot, but you can try it. And let's see what you get. So working forward, if you've already tried it, they found the moles of our NaOH first by using the molarity and milliliter to liter conversion. Then we can say that the moles of HCl and the moles of NaOH are the same. I would actually use a multimole conversion here. I would have done it this way. And I wouldn't have done it in steps. We'll talk about it in class, but I would use a multimole conversion instead of just saying, oh, it's the same. I know it's the same, but writing it out is really helpful. And then we'll take our moles of our acid divided by our liters of our solution. They're kind of doing it a little bit backwards here. I would just find the liters and then find the moles and then divide them. So you should be getting this number as your answer. All right, we'll go over this more in class, but again, this is a lot for the lab portion. I won't be doing, you might see like one question like this on a test, but it's not going to be a big portion.